This is a companion video for exercise 6 of architectural simulations. Last week we introduced Grasshopper in Rhino. You did an exercise creating a simple script and playing around with parametric facades. This week we're going to delve deeper, though we're supplying the scripts. And the point is we want to think about how we could use Rhino to generate geometric outputs early in any project as a way of helping us design intelligently. So, for example, we're going to today talk about stair cores. Not something you typically think about, especially in architecture school. At the beginning of a project, you're trying to be creative. You're trying to imagine an incredible space that really serves people. But the problem is, if we don't think about these practical things up front, then they get crammed in or glommed on later, and they can really mess up our design. So we need to be thinking about everything at the beginning, and these tools can really help us with that, so that we can sort of get that out of the way. We have, for example, in this case, we're going to generate stair core volumes that meet code requirements. Basically, at the beginning of the project, we would have these, they'd be baked and available in Rhino so that we could just kind of move them around and keep them in our thoughts as we're developing space. That's the idea. And what would that entail? So this is a stair core from a small apartment building. We have, stairs on one side and the other, and then elevators in the middle. All we're going to be designing or using our script to develop is one side of a stair core like this. Um, and the point here is that there are a lot of variables and they're code defined. So for example, the rise and run is going to be code defined, how this railing works. We're also going to have wall thicknesses, like on the exterior of the building, um, the interior wall between the two stairs. We're designing, in this case, U-shape, a core that's going to generate U-shaped stairs for a project. Um, the handrail diameter and the offset from this wall are all determined by code. So if we created a tool that allowed us to input these at any point during our design process and generate a core that is at least an example approximation of what we need, then that seems helpful and frees us up to be thinking more about design. So how would we go about doing that? Um, if I go to Rhino, here's a script that I built for this. And again, really all you're doing is you're going to, the blue are the inputs, and that's really all that you're going to be inputting for your exercise. But the point of this is to get you start seeing how you might generate your own codes. So I want to spend some time in this video showing you how this works. First, let's just remind ourselves that all of these components here that I'm using are just basic components to it's very simple calculations, and they're basic to Grasshopper. So for example, in the math tab, I've got, multiplication, division, etc. If I come back to this tab, I've got sliders, which, these are sliders down here. So this is all basic stuff that you have access to. It's really simple math. But if we were to try to do this on a spreadsheet, or, I mean, just on a piece of paper, uh, we first of all, we might mess it up. Secondly, it would be time consuming if we did this every time. So if we build a tool that has simple inputs that are clearly defined, then that might be productive, especially if we were doing a number of buildings, or we were in a practice, and we knew sort of the realms in which we were designing. We could develop tools like this, and they'd be helpful long term. Another thing I wanted to say quickly, though, is that so the boxes are you can combine sets of components graphically in Grasshopper by, if you just select them and you right click and you group, that creates a box like that. And then you can change the color, do whatever design work you want to on it. Or you can cluster them. So if I make a cluster, then this is all that code is in there. I can do whatever I want to with it in here, and then have a simplified graphic display. And so some of these components here are clusters. For example, this one is a cluster. And I've renamed them to make, so for example, if I right click on this, I can name it. Uh, so the idea is to organize your script so that it's, first of all, very clear to use, so you can use it easily the next time you open it 2 months from now when you're doing something, you haven't used it for a while. I could have put all of this in a single cluster and just had some inputs and outputs and completely hidden the inner guts, but I didn't want to do that because I want you to understand I'm doing two things here. One, making something that actually produces an output, and the other, um, uh, describing or introducing this interface. All right, so what's going on here? We have our, you'll remember from last week that this red volume over here is not actually in Rhino. I can't select it. It is a preview um, of the script output. So I'm turning it on. And if I want to actually make a stair core to use, then I have to bake it. And we covered that last week. I would hit bake, put it on a layer. So that's a pretty simple process. And then we have actual geometry that we can use in a different file. We can copy it. Okay, so then a basic setup here. We have a bunch of inputs on the left-hand side, some code, and then some outputs. So let's just describe this. Um, in the building specs inputs, well, number of floors, floor to floor distance, floor area. Those are all things that you should know from your program or from your design process. For example, if you don't know your floor to floor distance, you just make it up at this point. But as you get better at this, or as you get more experience as an architect, you'll have a pretty good guess. Especially if you become technically savvy. And for example, this floor to floor distance is going to be related to your HVAC system, because if you have ducting or you don't, and the size of the ducting. And we're going to do a script later in the semester to approximate that based on some decisions we're going to make about HVAC. So we could be using that right now too. Anyway, so these are inputs that determine essentially right now the floor number of floors and the floor to floor distance is determining the height of the stair core. Um, and so you just saw me adjusting those and how that adjusted the uh, our core out here. So what's next? We have floor area, which again we're gonna choose ourselves. This is the and when we're designing stair cores to code, we're talking about floor area. That means a single floor because the question is how big does a stair core need to be to service a floor? Big meaning width and length of the stair area inside, and also then the exterior walls and the interior wall that separates the stairs. Um, Okay, so those are self-explanatory, those three. Um, what's this occupant load factor? Well, that comes from the code. And so I want to just make a pitch here. Code now is available online for free. That used to not be the case. And I really suggest strongly that you start using the code if you're not doing so already. And when you're designing, I know it says it, in your the requirements for your, some certain thing in a class that maybe you look at the code. No, look at it all the time. It is a huge source of information that's very helpful. And if you get to where it's your friend and you are looking at it before you have to, then it doesn't become a burden. It becomes a design tool. So in this, for stair cores, we're going to be looking at means of egress. I should also say at this point, I'm talking about a workflow here. I'm a busy professor also. I'm not trying to say that this is a tool you would actually use in practice. I would have to spend a lot more time on it and make sure that and make it more robust. I'm just making something that's makes a point and is, I think useful definitely in your studio projects. Okay, so that's the code. What is this occupant load factor? I just did a couple screenshots to make this go more quickly. So we've got our code. We're in chapter 10 for egress. And that dropdown is from this chart, the occupant load. And you should know that the occupant load is the maximum floor area allowed per occupant. So we're going to take, so if we have 15,000 square feet, we're going to take the occupant load factor and divide the square feet by that, and we'll get the maximum number of occupants that we would be allowed to have based on the use type. So we'll see that, baggage claim at an airport is 20 gross. Um, whereas excess storage for mechanical equipment is 300 gross, meaning that we can have um, a lot more space per person um, for this particular use. Uh, Gross and net are the two options here. Uh, we can talk about it in more detail, but basically, essentially, gross is the total, and sometimes we're using net because we may, in that particular situation, take out furniture or there's some shared bathrooms or something with other spaces, and so we're just taking the net. Not worried about that too much right now. We're just trying to understand the concepts. So we're getting this occupant load factor uh, and putting it here in our script. What I have here is a drop down, and all I did was take those load factors from a few different, and I started with something that has a very small load factor, went up to a larger load factor, so we'd have some variety. This could be much longer. We could put the whole list in here if we wanted to. So what did I do? Now, like I said before, I've got my floor area divided by my occupant load factor. That's going to be our maximum occupants from the code. And so if I change this, I'm going to be changing, actually that didn't there, I can explain why. I'm going to be changing the dimensions of, and notice these don't all change it because of things that we can talk about. Because there are max and mins in here for, different components. So this is now we've got for our, let's just say it's residential, start with something that's um, common. Uh, so we have our maximum occupants. Now we want to, we're going to generate the width of a single stairway. Before I do that, let me just mention the obvious that the height of the building, like I said before, is the floors times the floor to floor distance. And so we can, that's what's adjusting this, and that's coming from here, coming into here. This little component is just saying it's an integer because some of these, let me do that. I'm going to bring in a panel. If I come from this without an integer, I get a fraction. I don't want a decimal place in these. I want these, because we don't have to be that exact. I want these to be clean, so that's why I'm using an integer here, just to take whatever output we're getting here and rounding it to an integer. Okay, anyway, so that's our height. To get our width, then we're going to bring in the max number of occupants, and we're going to look at the next code requirement, which is whether or not we're sprinklered or not. Why would that be of interest? So this is a cluster. I'm going to open it, and we can see here that we're saying here's the occupant load, and we're going to multiply it by this value here. What is this value? First, let's look inside this little code snippet. We're saying if X, that's the input from the sprinkler, is sprinkler, then make this 0.2. If not, make it 0.3. So what is that about? We come back to our code screenshots. We see that to determine the width of a stairway, um, the baseline is 0.3 inches per occupant. But if we're fully sprinklered, then it's 0.2 inches per occupant. That makes sense, right? If we're sprinklered, we can have a smaller space because people are in less danger, basically. They're not in as much of a hurry to get out. So we are then saying this is our number of our occupants times our multiplier to create the width. As simple as that. Then we have the minimum. Our minimum is 48 inches. So if this number ends up being less than 48 inches, this little piece of code is going to generate 48 inches. And that is why, let me close this out. That's why if I go between residential and warehouse, let's look at that again. So residential is 200 occupant load factor, and warehouse is 500, but they don't change the width of our stair core over here because of that 48-inch minimum. So if your head's already spinning, don't worry about it too much. I'm just trying to show you how this works. You can come back and slow this down and look at it more if you're interested. I'm hoping that some of you will be interested and see the power of this and start trying to generate your own little scripts. And the way to do that is just to say, okay, what is it I'm trying to do? What would I like to be able to repeat or adjust quickly, parametrically? How would I do that? And then you create a script with these nifty little components, and then see if it works. Okay, so sprinklered or not, no not sprinklered. Um, Another thing well, we'll talk about that in a second. Okay, so that's our single stair width. Um, but then that's just for, let's look at this again. Yeah, that's the single stair width for one stairway. But we have more than that. We have, so this is that input coming in. Um, we're going to multiply it times two because we're going to have a switchback stair. So we decided that. I don't know if I said that, but that's what I'm designing this stair here or a stair like that, like this. So I'm going to multiply that width times two. Then I also have the question of, how what's the wall thickness here, and what's this wall thickness, and this wall thickness. I'm bringing all those in here to get a full core width, and so just that's why then this input here is coming from things like uh, and we have other things, the handrail offset, the handrail diameter. We were talking about that. That's, how far is this handrail off of this wall? What's the diameter of that stair rail? Those are all things in the code, so I put those in. We have the exterior wall thickness, the stair wall thickness. That's the wall that separates the two stairs. Um, and those all together are coming in to make the full width of a stair core. And so that's what's coming from here to here. And that then becomes the output for our full core width, which is the smaller dimension here in this case. Okay, then you get the idea, but let's just continue on. So we've covered all of these. We've talked about how we get max occupants and how that creates a stair core width because we have a multiplier that's from the code. We got a height and a width now. So what about the length? The length comes from, um, we have to get a number of steps and then a length of steps. Then we're going to divide that by two because it's a U-shaped stair. And then we're going to get from this a number of inches. So for example, this is in this case, it's 104 inches. So how is that? Let me just do that again. So we're right number. So how do we get number of steps? For example, A divided by B here. So A is the floor-to-floor distance, and B is the stair rise. So that makes sense, right? Go back to this guy. The rise of the stair and the distance from here to here is going to determine the length of just of this stairway. And then, like I said, then we get the total here, and we divide by two because it's a U-shaped stair. That's how we get that. But now then, that is just, oops, that's just this length from here to here, right? Or if we come here, from here to here, we also have a landing, and we have again these walls at the two ends. So I'm adding those in here. The landing is generated. There's again there's a sprinkler input here. If it is sprinklered, it's going to be 48 inches. Um, is the Our landing is going to be 48 inches. If not, it's going to be 78 inches, and that's because of we would then need a refuge area like this for wheelchairs. This is where I'm getting a little bit loose with things. I'm not saying this is exactly right or the only way this would be configured. So there's be other ways of doing this. I'm just trying to make a tool that we can use in this class. But the point is, all those things came together to make this length, and now we have a core length and a core width and a height. Then the question is, how many cores do we have? That's determined by basically if we have less than 500 occupants on a floor, we're going to have two. If it's more, we're going to have three. So that's again back from the code and from our uh, max occupants values coming into here. Okay. Uh, all of that then generates By the way, so why did those just show up? It's because I've got um, the wire display set here to hidden. If I put it on default, then we would see it for just that one because I was only selecting that one. So I'm going to go back to hidden. If I click on it, we can see that where these are coming from, these three outputs. Um, so this particular component, let's click on it, says create a box defined by a base plane and size domains. So my base plane is down here. So that's this component, and then the x, y, and z are these dimensions here from our length, width, and height. And so that's how we get our stair core geometry. And then I can bake it, put it on a layer, and now if I turn off this, there it is. So I can move it and then turn this back on. And now we have both. Um, So that's the basic idea behind this. Let's delve into it a little bit deeper because there's some interesting things here, and things that you guys should check if you get into a situation like I'm getting ready to describe. Notice this. So that this looks like a stair core, right? This looks like what we're seeing here. Um, it's longer than it is wide. We're used to, if you have done much, commercial work, this is what they look like. Um, but what if we start getting into really different types of spaces. Like, for example, if we're going to, an office is about the same, but if we get into library or galleries, now we're actually creating a space that's a stair core that's much wider than it is long. That seems really weird. But if you think about it, if we had a ton of people in a gallery or an assembly space like a stadium, and you go look at the stairs in a stadium, they're very wide, like to go up to the bleachers, at a big stadium like MetLife. So that's why that dimension relationship between width and length becomes less intuitive. Um, but then if they're sprinklered, makes a drastic difference. So this is really helpful just to learn some basic stuff about the code also. All right, so there's a second half to this, which is the cistern modeler. Let's see, where was I? But the approach is pretty simple in the assignment. Read it. Let me know if you have any questions, and watch the next video.